Good morning once again. Okay, so I am back. The previous lecture, I had spoken about the addition of vectors. So wherein two vectors are being added as shown. Oops, my pen is not been observed. Just a moment. Yeah, it's safe. Right. Okay, two vectors were been added, and we saw like when two vectors have been added. So how to get the resultant vector? And as a result of this, I showed you about two examples. One of the example is when two vectors are perpendicular, how to get the resultant. And now we have also seen when two vectors make an angle, how to get the resultant. We have seen this also. And then I had shown about when two vectors are something like A and B. Okay, or maybe we can add two vectors like A plus B, A plus 2B, A plus 3B, and so on. Or maybe I can also take B minus 2A. I can subtract two vectors. So that is also something which we have seen so far. Now what we will do is, I said we will do something experimentally, okay, using GeoGebra. Okay, so what experiment can we conduct here? Usually when we talk about vectors, vectors is a dry subject. In the classroom, we just teach only in the board. But today, after long thinking long about what the way how I go with classroom is that I take up practically the website known as wophysics.com, and then I start using this. Okay. Now what I will do is let me share the website. Let me share my screen. Yes, I already opened it. And see what is the experiment that I can do. One can always ask me, what experiment can we do using just addition, right? Let us do that and see how we can do it. Let us go with vector addition and subtraction. Right. Just wait for a moment until it opens, and then we will begin with this. Right. Now we have two vectors. So this is the interface that we observe here. Right. Okay. Now in the previous lecture also, I had described the same interface, and I had shown that when two vectors A and B are equal, then the angle which lies between the resultant and the vector A, okay, is being bisected, or it's equal to half the angle between A and B. For example, if I show you, so let me make one of these vectors to be 100. The other vector also will make it 100. That means these two are equal length vectors. Plus I enter. Now you see here, I will make the angle between these two. See, between here theta A is 0 degrees. This is 0 degrees. And theta B is 68 degrees. This whole thing is 60 degrees, 68 degrees with respect to the x-axis. Now you see this black color vector, black color line that you observe here is nothing but your resultant vector, which is making an angle of 34 degrees, which is half of it. Then now I'm going to do an experiment to find out what is the effect of this angle if the length of this vector A is being varied. Okay, let me write down. I want to write it down somewhere about my experiment. Usually when we talk about an experiment, what do we need? We need to have two variables. So now what I'm going to do is I'm going to have two vectors which are at an angle theta, which we do not know. We can vary this value. And then what I'm going to do is I'm going to, as a result of this, I'm going to have a resultant vector like this. So I'm going to pull this vector, put it over here, because this is my tail, this is my head for the first vector. This is my tail and this is my head for the second vector, right? So I have pulled this vector in this way, and thus I have drawn a resultant vector like this, right? And then this is my tail and this is my head. As you observe, the two heads are coinciding. The two tails of the resultant vector, maybe I should have drawn this using a different color. Okay, let me do this. Yeah, I take up this color and I will draw on top of it. This should be my resultant vector. Maybe I'll take up a new slide instead of this. So what I will do is, let me go back to this. Click here. I've taken two vectors. This is my vector A. This is my vector B. And this is my y-axis. And this was my x-axis. Vector A was coinciding with vector B. Now, as a result of this, I want to add two vectors. So the rule that I follow is first draw the T and H for both the vectors, T and H here, and here H here. And maybe I'll remove this X over here, bit of confusion. And then what I do is I pull this vector because you see the tails of these two vectors are coinciding, which I don't need. So I am pulling it over here. So I will write over here the same parallel vector so that this becomes T and this becomes H. Then I am going to draw the resultant. The resultant, I will use a different color pen. So I will take up this color and I'm going to draw it like this. Right. Now you see the head of the resultant vector and the tail of the head of the resultant vector coincides with one of these vectors, and the tail of this resultant vector coincides with the other tail of the vector. Okay, so we have got this now. Now the question that I have here is that if vector A, okay, let me go back, let me switch over to my red color pen. If vector A, if the magnitude of the vector A is equal to the magnitude of the vector B, what do you mean by that? It means the length of this vector is equal to the length of this vector. Let us say both are something like 5 centimeters length. Then, and the angle between them, the angle between A and B. What is this angle? Let me call this as angle AOB. Angle AOB, okay, is equal to, let us say, 60 degrees. Then we observe that the resultant vector bisects the angle between A and B, angle between vector A and vector B, which means what? The angle of resultant with the horizontal, what has happened to this? Horizontal will be equal to half of the angle, initial angle, which should be theta by 2, which should be 30 degrees. This is what you should observe. This is your 30 degrees. This is what you should observe if this angle was 60 degrees. Okay, this is true for every angle, whatever could be the value of theta, this should be true. Now the question is that I want to change one of these lengths. Okay, see, if I have put here, if the lengths are equal, this is correct. Now the question is, if the length of A is increased, then what will be the angle between, the angle between the resultant and the vector A? What I'm going to do, I'm not going to keep these two constant. These two vector length will no more be constant, but I'm going to keep B constant and value of A would be varied. And I'm going to ask what will happen to the resultant vector. Okay, this is my research question. Okay, see, from a very small perspective, we are looking at research also, right? Okay, will this be called as research? Research is always something like you explore, right? You need to explore something, okay, however small it could be, and then decide, design a methodology, okay, a systematic methodology, collect the data, then analyze it, then interpret it, then evaluate and say, yes, this is what I have got. Okay, so now this is what we are going to do it. So this is what it is. Now from here, I should refine this. This is my research question. I do not know how does the angle change. This is what I have. Now my hypothesis, I'm going to put it as to what extent does the angle theta change when what extent does the angle, not theta, maybe I'll call this as angle alpha. Okay, what is this angle? This angle is alpha. The angle alpha change when one of the length of the vectors is varied. This is what I'm going to do. Okay. So which means, now once again, what do? I'm going to vary what? I'm going to vary length of a vector A. Okay. This is what I'm going to vary. Vary the length of the vector A. Vary the length of the vector A. And then what am I going to determine? What is it I'm going to observe? I'm going to observe the angle made by the resultant with the vector A. This is what I'm going to observe. Okay. Now towards it. Now the first thing in any research is we need to find out what is my independent variable, what is my dependent variable, what is my control variable. Okay. Now independent variable is something like you can vary it independently and this will not have an effect on the experiment. Okay, whatever you do here. So therefore, you are free to vary. So this length of A is your independent variable. Now, when you specify an independent variable, see this particular video is aimed in understanding how to do research. Okay, it is not for one particular section. Okay, if you say whether this is for CBSE syllabus, ICSE, of course, I don't have any answer for this. Anybody who wishes to do a research, okay, and think, oh, I have to find a research problem. And finding a research problem, how do I find it? Should I search for journals? Need not be. Okay, you can think about anything, okay, which you already know, and systematically you devise a story. That's what you are doing in research here. Now towards it, you are varying the length of A. This is your independent variable. When you specify your independent variable, the independent variable should be changed systematically. What do you mean by systematically? What did we say? This is my vector A. This is my vector B. And then what did I do? I'm going to change the vector A length. How am I changing here? Let us say initial length of vector A and vector B were 50 centimeters. 50 centimeters over here. Then what do I do? Or maybe, yeah, 50 centimeters. I'm going to increase this. By how much? Let us say I'm going to increase it by 55. 5 centimeters more I'm going to increase. Okay. So systematically, I'm going to increase 5 centimeters, then 10 centimeter, 15 centimeter, 20 centimeter. You see, between every observation that I do here, my variation is only 5 centimeter. Okay, which means your first observation would be 50, second one would be 55 centimeter, third one would be 60, fourth one will be 65 centimeter, and so on. Right? This is what you get over here. Right. So now systematically you are going to systematically vary the length in steps of 5 centimeter. Now the question here is this: how long are you going to vary? Are you going to move for 100 kilometers? No. Okay, we are going to stop it at maybe 5 observations, right? So not more than that. 50, 55, 60, 65, 4 observations already done. Maybe I will take until 75 centimeters. 75 centimeters. Until 75 centimeters, starting from 50 centimeters. You know, this particular paragraph is very, very essential. Okay, if you don't write this, you will not get to know how are you going to vary your independent variable. Right. So you have mentioned everything about the independent variable. The next is dependent variable. What is a dependent variable? Angle made by the resultant vector. When you are adding 2 vectors, now this would be the resultant vector, this would be the resultant vector. So therefore, what is the angle made by the resultant vector? I have not told you how does the angle vary. We are just going to determine this. So this will be called as your dependent variable. So you need to write this. Angle made by the resultant vector with vector A. Now you can ask me always, see, why can't I vary this also systematically? Why this statement is absent here? You can say that you cannot use it. The reason is because you cannot vary this angle here. This angle cannot be varied at your will. This angle will vary because you are pulling this length here, right? So therefore, you cannot say anything here. You have to stop here. The next one is about your control variable. What is your control variable? Something you are going to control. most of the students make a mistake when it comes to control. They think I am controlling a variable, that is a control variable. That is completely incorrect. A control variable is one wherein which is kept constant throughout your experiment. Because if you change the control variable, the experiment changes totally. Your hypothesis will go wrong. Okay, nothing wrong about going wrong with the hypothesis, but still, okay, so your hypothesis is not being verified appropriately. That's what will happen. So control variable, remember, control variable is a variable that is kept constant. One more misconception many students have is that when I talk about a control variable, they'll think, sir, can we consider that paper is a control variable? Because, I'm going to use a notebook to write something. Can paper be a control variable? Definitely no. Okay, because you should be able to measure that. And secondly, the variable should be present in the experiment. And altering that paper, okay, will not change your experiment, right? So that is not your control variable. Now, what is the control variable? That is what we need to discuss. The value of B. See, I am not going to change the value of B. For example, so here, what are the control variables? Vector B. Vector B. What is vector B? This vector. Now, vector B, should it be here? I will say the magnitude of vector B and position of vector B will be held a constant, which means throughout the experiment, I am not going to change this. This is what I'm going to do. Okay. Now how am I going to keep it constant? So initially, what I do is I will consider that vector B is perpendicular to vector A. Why perpendicular? You can ask me that. Okay, this answer would be evident when you finish your experiment. Okay, let us begin with the experiment first. Right now, so after this, now we have done with the variables. The next thing is there any problem while doing this experiment? Is there any hazard? Is there any kind of dangers associated with the experiment? Can you talk something about your risk analysis? No, there are no risk associated with it, right? There are no risk. So you can easily do the experiment because you are doing it in a computer. You're not going to use big sticks over there, right? So therefore, no risk involved. Okay. Now let us move on to the experiment. Let me introduce a new slide because I need to record the readings also. Any experiment, remember, if you don't enter the readings, then that is not called as an experiment. Okay. So we need to record the readings. Now to record the readings, what do I need? I need a tabular column, right? Many of them write an incorrect tabular column. We should write a correct tabular column. In a tabular column, what do we have here? We have initially SL number. And then what do we have? You have an independent variable. I will write on top. Independent variable. What is your independent variable? The length of vector A. This is your independent variable. When you write the length of vector A, you are measuring this in some unit. Mention centimeter, right? You are measuring it in centimeter. Next, what is your dependent variable? Dependent variable is angle made by resultant. Resultant with vector A. This is your resultant. Hey, why did I put a big row here? Why did I put this width to be larger? The reason is because I want to have trial 1, trial 2, trial 3, and then I have to stop it here. I'm not going to write anything here. I'm not going to write anything over here. Okay. Usually what people do is they will write everything. They'll put the average also here. I'm not going to put that here. Okay. For some reason, right? T1, T2, T3, and I'm missing something here. What is it? Units per centimeter. Hey, is it in centimeter? No. This is in degrees. This is in degrees. Okay. T1, T2, T3 are the 3 trials. You are going to measure it in terms of degrees. Okay, let us begin with the first one. Now let me go back. Let me share my screen with the laboratory here. There is a laboratory page. My page is here. Okay. Now I come back to my laboratory page. Now, first things first. Now, what do? We need to start the experiment. Put the value of A to be 50 centimeters. We'll make this as 50 centimeters over here. And then the value of theta is 0. And then the value of B, let me keep it also at 50 initially. Okay. And then I said that B would be kept at 90 degrees. I'm not going to change this. B would be kept at 90 degrees. See, this vector A and vector B, both are seen to be equal. And then the angle made by the resultant is seen to be 45 degrees. Now I need to record these values. Let me share my screen backwards. And then I will write it down here. So what is that I'm going to do? I'm going to write A. Before that, I'm going to write vector B is equal to 50 centimeter. And the angle, initial angle, okay, I will make the angle theta to be equal to 90 degrees, theta initial. Okay, what is theta? Angle between A and B. Let me write this also. Angle between A and B. This is constant initially for the first trial. So I am going to write this as 50 centimeter over here. And what is the angle made by the resultant? If you look at this, what was the answer I got over there? See, angle made by the resultant is 45 degrees over here, right? Okay, let us take that value and write it down. This is 45 degrees. Now, if I do 3 trials in a simulated experiment, do you think any difference will be got? You will not get any difference because it is a programmed experiment. Somebody would have written a program there, so you will not get anything. But if you do it physically, probably while you do an experiment, physical setup, you might get a difference. Okay, so that's why we take 3 trials to eliminate the random errors. So here you won't get any random errors. You will get the same values. So 1 trial is sufficient. You don't need 3 trials here. The first observation is done. What's the next step? I am going to increase this by 55 centimeters. But I am going to see to it that the angle between A and B is always held constant. Now let me go back to my lab. And then I'm going to increase this by 55. So what should I do? I can either move the slider here or I am going to keep this at 55. Type in this value, enter. And then you observe this is no more 45. I am getting this value to be 42.27. What is this angle? Angle made by the resultant over here. Now let me go back once again. So if I increase by 5 degrees, the angle I got is 42.27. 42.27 degrees. I'm not going to write anything over here, okay, because it's one and the same, right? The third one, I make this as 60 centimeter. I will increase it by 5 more units. Next, what we do is, let me go back to this and let me change this value to 60. What is it I have got? 39.81 degrees, right? 39.81 degrees. I should remember this here, otherwise I will forget. 39.81 degrees. Wow. Fourth trial, 65 centimeters. Right? I'm increasing incrementally here. Okay. Then I will go back for 65 centimeters. 65. I'm making this to be 65. See, the value of B is held constant. I have not changed. The angle between A and B is also held constant. I have not changed because these were 2 control variables. Now what I am changing here is only this one, okay, which is 65 degrees. 65 centimeters. Make it 65. The angle now reduces to 37.57. Once again, 37.57. So 37.57 degrees. Fifth trial, 70 centimeters. I need to have one more also. One more also. Okay. Sixth one is 75 centimeters. Okay. Now what we do is 70 centimeters. Let me reshare it once again. Go back to my lab page. 70 centimeters. What should I do? I should change here. 70 centimeters. What did I get? 35.54. See, it is reducing like anything. 35.54. Write it down. 35.54. Then 75. Finally, one more. Last trial we will do. 35.75 centimeters. Go back to my lab page. Make this as 75. And what do I get here? 33.69. Let me change this. 33.69. 33.69 degrees. Now you see, it started with 45 and started coming down and just come here. Now let us say, for example, if I ask you a general question, let us say, if I keep on increasing this length and I say, if I go to something like I had 50, let me say this is 200 centimeter. What do you think can happen? What do you think can happen? Okay, some trial, 200 centimeter. Will this become zero? Will this become zero? This will not become zero, right? This won't become zero. Let us try it out. Okay, I am very curious to know this. Let's try that also. 200 centimeters. 200. Where is this 200? I'll change this to 200. Become 26.57 degrees. Wow. Okay. 26 point. Hey, what was the answer I got? I forgot this. Just a moment. Let me see. 26.57. 26.57. You know, in physics, this is what drives our curiosity. You know, we'll be interested to keep on conducting like this. Okay. Now what I will do is, I want to do one more trial. Anyway, it is in silico, right? While doing computers, I'm not going to break anything, right? So let me make it as 20,000. Okay, very, very long. Okay, I need not spend any money on this, right? Let us do this also. 20,000 centimeter units, whatever has been mentioned, to find what is the angle I get here. Wow, this would be quite interesting. So yeah, let us see that. 20,000. This higher. Oh my God, I should not change this. Sorry, this is what I should change. What did I do last time? Did I make a mistake over there? I said 200, right? I think I made a mistake over there. 200. For 200, what is the angle I should get? Oh, it cannot go beyond 200. Oh, it goes only to 100. See, this is what happens. Okay, when you are doing a simulated experiment, don't think that whatever you do, you will get the answer. Okay, because they had written it in such a way that you will not be able to vary beyond a given extent. Okay, so therefore, now the maximum given here itself is 100. You can't do anything. Okay, fine. So anyway, we will stop here. Now let me go back to my results. So therefore, definitely these two results, we didn't get it. This is completely incorrect. Okay, I didn't notice it. You need to look at it very carefully. Okay, so we have it done until so much here, right? Now, what do we observe here? Now, see, this is known as an infographic. Infographic is something like it gives you information about the experiment, about the data that you collected. So every infographic will have three important elements. Okay, any table, any image, any kind of bar chart, whatever you draw, okay, will have three important elements. The first element is that you should mention why did you do this? Okay, why did you write a table? Suddenly in your report, most of the students do it. Okay, they write about everything. Suddenly they put this table. Okay, and there'll be multiple tables. One table here, second table there, and I don't understand for what purpose it is being done. So there should be a method to write it. So what we need to write is we have to say in order to determine the dependency, or you can say relationship between, okay, between what? Between the length of the vector, length of one of the vectors and the angle made by the resultant, the experiment was conducted as described above. Where did we describe? In the procedure section, we would have already described, right? We would have described we need a computer, we need to have this Geogebra installed into it, or maybe we can use the online mode. Okay, and then we would have said that, okay, we are using this website, and I'm going to keep this one constant, this one constant. We would have mentioned all this, right? I'm going to vary it by using the check boxes. Everything we have mentioned over there. So thus we are now relating it. Remember, one part of your report should not be completely independent from your previous parts. It should be linked to it. Okay, so thus we are linking it over here. So this is the first part. Okay, so I said that every infographic should have three elements. The first part is nothing but this part. That means we are referring it to the previous one. Okay, and angle made by the described above and then the readings are as tabulated in table 1. Okay, very, very important. We need to write this. Now, the next one. Now we have already done the first one. So that means the moment I read this, I'll get to know, oh, you are doing this experiment for that purpose. Okay, I need not scroll back and to understand what is it about. The second step, what we do here is that. Second step, what is it? The legend for the table. Legend for the table. What is legend for the table? It should say, okay, this is table 1, variation of length. Okay, table 1, variation of length versus alpha. This should be shown. Okay, this should be written over here. Because why this is essential is because somewhere in your evaluation or somewhere in the bottom of the article, you would be mentioning, okay, this particular table. If the table name is not there, how do I mention it? Okay, every table should have a name. Then lastly, inference. Now, what do you infer from here? See, as the length of the vector is increasing, what do you observe? The angle made by the resultant vector is decreasing, right? This is the inference. Okay, you're not going to get a big inference over here. Whatever you have observed from your raw data, this is your raw data. Raw data, you need to mention. Okay, thus, now what you are going to do, you have done your data collection, you have mentioned your hypothesis, you have done your independent variable, you have coined your variables, you have determined what would be your dependent variable, control variable, and finally, you have recorded the trials, and thus you have written your infographic also. Okay, thus doing an experiment is not a great thing, but documenting the experiment is very, very essential. Okay, so thus today we have learned until so much. Now, as we keep on going for the other lectures forward, okay, when the data analysis becomes more and more complex, okay, so I will be introducing many new terms over here, how to write a report. The lecture series that I am going to have here, or we will be having over here, okay, is only aimed at how to conduct an experiment. Okay, first I'll be teaching about the physics concepts, and then we will be looking at how to conduct an experiment using this. That's it. And most of the time we'll be doing only online simulations. Maybe if I get more time, I can also conduct something like a real scenario, okay, wherein a real experiment could be conducted. So science, as I always say, it is not about using complex instruments. Science is always about understanding the complexity of an instrument by applying relevant laws. If you understand the science behind it, then there comes the curiosity, there comes the understanding, right? Thank you, friends, for watching this. So we will meet in the next class, in the next lecture, okay, to know more about vector. We have already seen vector addition. Maybe we'll look at some new topic on vectors, or maybe I may move on to the kinematics. Thank you.